Hi everyone! This episode's movie is The Hunt for Red October, and we're using it to explain cavitation. It's a physical phenomenon that is rarely heard of in popular culture, but it's a very common occurrence with ships and other marine craft. Cavitation is mentioned during the cat and mouse chase scene between Red October, the Soviets' new stealth submarine, and the USS Dallas. The Dallas's propeller begins to cavitate, at which point someone mentions that the Red October can now hear the Dallas on sonar. This is one of the reasons why cavitation is so dangerous for naval vessels. Everyone and their mother with a sonar can hear a cavitating ship. Okay, so what is cavitation and how does it work? First, let's have a quick flashback to science class. Each substance, like water or steel, has 4 different phases: solid, liquid, gas, and plasma. There are 2 different ways for a substance to change from one phase to the other. You either change its pressure or you change its temperature. The phase change from liquid to gas you're most familiar with is boiling, increasing the temperature of water at a constant pressure until it changes to vapor. This is called the boiling point of a substance. Cavitation is the exact opposite, the transition from water to vapor by decreasing its pressure of the fluid at a constant temperature. This is called the vapor pressure. So now you're wondering what this has to do with submarines. If a propeller of, say, a submarine rotates too quickly, the water surrounding it will cavitate. Here's why. Centuries ago, a smart guy named Bernoulli discovered that the velocity of a fluid is related to its pressure. So increase one, the other will decrease, and vice versa. So if a propeller gets the surrounding water to move so quickly its pressure drops below the vapor pressure, then bam, cavitation. So I know what you're thinking. Bubbles show up on propellers, so what? Well, those bubbles cause massive amounts of damage. See, cavitation on a propeller's blade isn't the steadiest of conditions. Those bubbles collapse pretty quickly, and when they do, they create this incredibly fast microjet of water. This microjet easily damages all metals, leaving tears and holes. This reduces the efficiency and effectiveness of the propeller. And as I said in the movie, the collapsing of these cavitation bubbles makes an insane amount of noise. So cavitation is going to put a limit on marine craft. Go too fast and you significantly damage your propeller. Even worse, if you're trying to be stealthy, cavitation can practically shout your location to anyone with a sonar. So engineers have spent their lives studying and designing around cavitation for a very good reason. So The Hunt for Red October is a movie dear to my heart for several reasons. 1, my grandfather was actually a commander of a submarine during that time period. 2, I have a master's degree in marine engineering, and 3, the movie's incredible attention to detail concerning the science of submarines. So props to Tom Clancy for writing such an awesome and well-researched story, and to John McTiernan for bringing it to life. Join us next time when we talk about Pixar's Finding Nemo and its depiction of EAC ocean currents.